Hi, welcome to our math. Today I'm doing a series of videos on combination and permutation. All right, a number pad is made up of numbers in the letters A, B, C, and D. If an entrance code is 5 digits long, how many codes are possible if? Okay, repetitions are allowed. 66666. If you can have repetitions, that means for each of your 5 digits, you have 14 options available because you have the numbers 0 through 9 plus the 4 extra letters. And so 14 to the power of 5 is 537,824 possibilities. If repetitions are not allowed, then you have 14 options for the first and 13 for the second and 12 for the third and 11 and 10. And though that's fun to type into your calculator, whenever you have this kind of truncated factorial, you can do the permutation of 14 taken 5 at a time and get that the total number of codes, if you're not allowed to repeat a digit, is 240,240. Okay. What if there has to be at least one repetition? When you're talking about repetitions, this is kind of a fun concept. You could have 0 repetitions, you could have 1 repetition, you could have 2 repetitions, you could have 3 repetitions, you could have 4, or you could have 5. And if I wanted at least 1 repetition, I have 2 choices. I could either calculate 1 plus 2 plus 3 plus 4 plus 5, which is doing a lot of calculations, or I could calculate the total, which I just did up here, minus 0, which I did right there, and subtract them. So every time I see the words at least 1, in my head I think total minus none. So to do total minus none, really we're doing 14 to the power of 5 minus the permutation of 14, 5. Now, I could have written these long numbers out, but that's 12 digits, and that's way less than 12 digits. And if you have a clever calculator, you can just scroll up to this and subtract your previous answer, and calculators are fun. Anyway, so you do this minus this, and you get 297,584 codes with at least 1 repetition. Okay, what if the first digit must be a letter? So again, we have a 5-digit code. The first digit must be a letter, so that means there are 4 options for the first digit, the A, the B, the C, the D. And then for the next 4 options, again, we have 14, 14, 14, and 14, and we're multiplying this all together. And we end up with 153,664 codes for that one. And last it says every other digit must be a letter. This one's tricky. So letter, every other digit must be a letter. Letter, letter. If every other digit must be a letter, it implies every other one is a number. So letter, number, letter, number, letter. But does it say that it has to start with the letter? What if it went number, letter, number, letter, number? Haha. So you have to account for it starting with the letter or it starting with a number. Each of these represents every other letter, every other digit being a letter. And when we calculate this out, we get 22,400. All right, I hope you enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.